So welcome to the art of architecting multi-site Kubernetes in a persistent way. Let's start off with defining a Kubernetes cluster. So out here I have a Kubernetes cluster. One. So this cluster consists of several components actually. Naturally you have a number of control nodes. So I'll just draw these in here. So here we have the three control nodes, and then we have a number of worker nodes. 1, 2, 3, worker 2, worker 3, worker 4, and 5. So this is capable of running containers, right? We have the control plane here. We have basically the data plane over here, which are the worker nodes, and on these worker nodes, we can spawn these little containers, right? So here we have a container running. So this is all well and good, right? It is a single data center solution. So this may run in data center 1. So, but now there's a problem, because as this becomes more interesting, it becomes more business critical. All of a sudden we're like, yeah, but here we have data center 2, and we actually need a way of getting that across there. In case of a failure in data center 1, we need to be able to keep it running there. So the pure cloud native way of solving this is by simply saying, well, let's add another cluster. So I'm going to have Kubernetes cluster 2, which has a similar setup. Yep. So I'm going to have my 3 control nodes, and then I'm going to have worker nodes here. And whatever I deploy here, I will also deploy, like this will be like replica 1. I should always have another container here that has replica 2, and then I need to somehow load balance these across from a global load balancer. And then whenever I lose a site, I will lose half of the instances, but I won't lose access to this particular service, nor any service, as long as I spread them across. So that's really cool in a perfect world, but since we don't live in a perfect world, we see more and more customers wanting to do it in a smarter way. So using this, you would always have to deploy left and right. So if I was a developer, so here you can see the developer, right? In a perfect world, he would have a CI/CD pipeline, and whatever comes out of the pipeline, he would just deploy left and right, always keeping these two in sync. So that's relatively easy to do if you do it the right cloud native DevOps way. If you don't do it that way, then this may all fail. So this is one approach. And because of these issues and keeping them balanced and all of this trouble, customers have been looking at something else, right? So you can actually say, oh, why don't I just, I'll leave the developer in here. If I have DC1 and DC2, why don't I just stretch Kubernetes across these two data centers? Right? So now I have a single Kubernetes cluster, but I'm stretching it across 2 data centers. So now a developer that comes in, and however he deploys it, you just need to deploy it onto one single cluster, right? It's relatively simple. The question then becomes, where do I put my control nodes? Where do I put my worker nodes? Well, worker nodes is easy, because simply put, I'm going to put worker nodes here. Worker 1, worker 2, and then on this other data center, I'm going to have worker 3 and worker 4, for example. That's the easy part. But now, control plane nodes. Let's put one here. Let's put one here. So where do I put the third one? A lot of people tend to think, well, we'll just put it anywhere. So let's put it here, C3. So this works, but it has a problem because now I have 2 control nodes here, 1 control node there. So imagine that this would happen. Oh, wait. So I'm going to lose data center 2. Right. With the loss of data center 2, I'm losing 2 of my control plane nodes, leaving only 1, which is not a majority of nodes. Answer is the cluster will go down. Even worse, if I were to get it back, say, okay, so let's delete the crosses, it's coming back. These 2 containers, they were killed at the exact same time. When they are powered up at the exact same time, in cases, these won't come up properly, right? They won't be able to solve their own, so who is latest, who has the latest updates, they won't be able to solve that in many cases, in which case the cluster will stay down. And basically when you talk like people like from Red Hat OpenShift, they'll tell you to potentially you need to restore etcd to these control plane nodes in order to get the cluster up and running again. Of course, that's not something you can work with. So what the general consensus is here is to say, don't put the 3rd control plane node here, but instead take, oh, that's not nice. Let's do it in black. Instead, take data center 3 here and have some infrastructure here and basically run your control plane node here. So now you have got 3 data centers. 2 of the data centers are running workloads. The 3rd one is just running a control plane node. So now I have a control plane node in each data center. Whichever data center I lose, I always have 2 control plane nodes left, meaning that I will still have a majority of nodes and the cluster will survive a single outage of any of these 3 data centers. So that works. But now comes the complexity of something else called persistent storage. So please join in the next session where we'll be digging into how to add persistent storage to Kubernetes, and even better, how to make that multi-site capable. Thanks for watching, and please stay tuned for the next episode. Bye-bye.